Hello, this is Darshan Senthil. In this video, we shall be talking about limits. It's our first concept in calculus. It's pretty important. So, what I'm going to do is I'm just going to introduce you to it and introduce you to some basic calculations you'll be asked to do with limits. And hopefully, this will prepare you well for when you actually study calculus formally in class. Okay, so let's go. So let's start again by defining what a limit is. So what is a limit? So the limit is a concept of how a function behaves as it gets really close to something. And by something we mean specifically some x value. And how it behaves, this is synonymous with how it behaves as it's what y value it approaches. Okay, so in other notation, this sentence is basically a limit is the concept of how a function behaves or how a function, what y value a function approaches as it gets really close to some x value. Okay, that's basically what a function is, what it is. Now I'm just going to help you grasp the concept of what a limit actually is and what it sort of describes. I'm going to give you this little analogy here. So let's say you're doing some bunch of tests in school and you're getting grades for them, obviously. So on your first test, you unfortunately get a 70. Okay, and you're all sad. So then you decide to study harder next time. You get 100. Good job. But then you want to keep that spirit going. So you get 100, you get 100, you get 100, and you get a 95 here, but you get 5 points of extra credit, so you get another 100. Okay, so you get 5 hundreds and then that 170. So now to help illustrate the concept, let's go ahead and calculate your average at each of these points. This is just basically the sum of the scores divided by the number of scores. So your average at this point would just be 70 by 1, which is 70. Here would be an 85, here would be a 90, here would be a 93, here would be a 94, and lastly a 95. Okay, so as you can see, we're getting close and closer. If you kept going down more values, you would get really close. Like if you go to like test 100, I'm not sure you can see that. If you go to like test 100, you get really close to like, you get like 99.999. Okay, so here's the thing. You will never have a perfect average of 100. Okay, that's the sad reality. Okay, that's just since because you have that 70 there, your average can never possibly equal a perfect 100. However, let me ask you this. The further down you go, you're getting really closer. Like you get 99.99999. Let me ask you this. How far apart is 99.99999 from 100? How far apart are they? Not much, right? In many cases, this 99.99999 is almost the same thing as 100. It's about, sometimes it's just rounded up, so it's the same thing as 100. So here's your statement of encouragement. However, you can get so close to 100 that it won't make a difference. Okay, so you will never have 100, but you can get so close to 100 that it's almost the same thing. So you can get like 98.99999, and you can get that you get so close to 100 that it barely makes a difference. So in like your calculations, that would just be the same thing as 100. Okay, so that's the concept of what a limit is. So you get really close to something, but you don't actually get to the something. Okay, so let's go on. So how do we annotate a limit? This is a big part of math. So we annotate limits as follows. The limit, which is this lim here, as x approaches some value, I'm just going to put c, of f of x. That's how you note it. So this literally reads the limit as x approaches c of f of x. Let's replace this with some more traditional vernacular. So the limit is basically a y value you approach, and as x approaches, that's approaches is basically gets really close to, as you get really close to some x value, and this is basically going to be the y value that you approach. So in common words, this is the y value that you approach as you get really close to some x value. Okay. And another way you could write this notation is you could write an actual function in there. So you'd have like the lib as x approaches c of like x plus 3. You could have something like that as well. Or they would just say somewhere later that f of x equals x plus 3, and they would give you this thing right here. So there's different ways to write it. It's the same thing. Okay, let's move on. So how do we evaluate limits? So there are 3 different ways we can do this. One is numerically using a table, and this is something similar to what we saw on the first slide. So I'm going to talk about this in this video really quickly. It's not a very hard thing to look at, but it's still worth talking about anyways. Then graphically, we use a graph. We use the graph of the function to try and evaluate the limits. This one I will also talk about in this video because I feel it really helps you firmly grasp the concept of a limit. And analytically, this is something that requires a little bit more talk. So I'm gonna spare a separate video just for this. And this is using algebra. So use algebra to evaluate a limit. It's not that hard, but it requires a couple of things that we need to talk about. Okay, so these are the 3 ways we can evaluate a limit.